we will continue our journey toward AI literacy. So, in this course, we are going to learn about prompt engineering. Prompt engineering is basically learning to talk to computers or learning to talk to language models or the agentic AI that we have right now using natural language. So far, we have mostly communicated with machines through programming languages like Python, Java, and C++. But recent innovations in AI and machine learning have enabled us to communicate with machines and um, like language models using natural language. We already communicate with other humans in natural language every day. However, even though prompts use the same natural language medium to communicate with language models or AI, language models still needs clearer instructions and better context than a human person would. And there are reasons behind that. Maybe we'll have a separate discussion on that, like how human is able to fill the missing gaps while language models cannot. And that is why prompt engineering matters. There are best practices and patterns that consistently lead to better communication with language models for better results. By the end of this course, I expect you to use these techniques for your projects, brainstorming, for your studies, and even planning your daily course. The course is divided into two parts. The first part will cover the theory of the topic. In the second part, we will spend extensive time doing hands on practice with prompt engineering. This part that we are doing today covers the theory of the topic. Let us now understand what a prompt is. A prompt is the message you send to a language model, often wrapped with additional context that helps the model respond the way you want. If you look at the picture, you'll see human to human conversation versus human to the model conversation. When two humans talk to each other, both people or both of them usually share a common understanding of the world. That shared world model helps us means the humans, communicate quickly and efficiently because we do not have to explain every detail. Right? With language models, that shared understanding is not automatically there. So the prompt becomes one of the main techniques we use to shape the AI's or the language model's understanding of what we mean. In other words, prompts are a natural language way of telling the model what you want it to do and what information it should use to do it. We said prompts are a way for humans to communicate with language models. So you might be wondering, what is language model? What is a language model? So think of it like a super advanced autocomplete. It learns language patterns from a huge amount of text during its training. That training creates a complex mathematical equation with billions of learned parameters. Basically, billions of parameters that help it predict what word should come next. We humans do more than that. we have real world experience and shared reality of the world. A language model is amazing at language patterns, but it does not automatically know what you meant unless you show it through context. If this still sounds complex, just know that the equation for predicting the next word can be represented like this: y equal to function of wx plus b. Here w represents the parameters the model learned during training. The model takes a previous word or previous words represented as x, multiplies by the weight, adds a bias term, and produces the next word prediction, which is the y part of it. This is a very simplistic representation of how a language model works, but this is just a representation. In actual, this equation is very complex, and this equation has many parameters which it uses to calculate the next word, right? That's why you will see when these models are released, it says, okay, x billion, this model has x billion parameters, right? So that is how complex these mathematical equations are for a language model. Okay. So this parrot image is the perfect metaphor for language models. A language model can produce words that sound confident, like a parrot. But if you do not give it enough context, it may guess, and guessing can still sound very convincing. So, the goal of prompt engineering is not to trick the model, the goal is to reduce guessing. It is also known as hallucination, by giving the model or the language model clear boundaries and the right information. And here is an important point: hallucination or guessing is not at all a bug. It is a feature of the language models. It is a part of how language models work. They are designed to predict what comes next, and when information is missing, they fill in the gaps using that prediction. Our job is to learn ways and techniques to control and guide that behavior so the answers become more accurate, more relevant, and more reliable. So, what do we do to control that guessing part, to ensure that the language models does not hallucinate? We engineer the context for the model so it can answer the question or answer your question in your situation with your constraints. When I say your, it is most like aligned to your use case. If the model is guessing, it is because we did not give it what it needs. Or, in other words, if it is hallucinating, we have not given it enough context to produce what we want it to produce. Context engineering is like setting the stage before an actor performs. The stage changes the performance. Now, context engineering is not just one thing. It is not just writing a better prompt. It involves shaping the right context for the language model, and that takes more than just good wording or good way of crafting a prompt. First, you need the knowledge to be organized in a useful way. When I say useful way, it needs to be organized in a way that the AI or the language model can consume it, right? So that the information is structured and understandable by the language model. That is what is termed as knowledge modeling here. In this picture, if you see, there are a lot of unstructured knowledge corpus. The knowledge modeling helps to create that structure and the representation of the knowledge into a knowledge graph which the AI or the language model can now easily navigate and use. Second, you need a way to retrieve the right pieces of knowledge for the current question or input, right? So as a user, if I'm giving a query, the query should be able to get mapped into that knowledge graph and then retrieve the right slice of knowledge or the right piece of knowledge from the knowledge graph to provide an answer or to provide an output, right? And there are many techniques of this retrieval or search. In fact, one of the critical part of making this language models work is to find out how you can optimize your search. And the third part is the need to do effective prompt engineering. How you ask, what role you assign, what constraints you include, and what output format you want. In real life AI based or language model based application development, these three work together. So the language model is not just guessing from broad general patterns, instead, it is responding based on the most relevant knowledge and clear instructions. In this course, we are not going to deep dive into this first two stage. Our main focus will be the third stage, which is the prompt engineering part, the practical skills you can use immediately. So it starts like the context engineering starts with knowledge modeling, right? Where we take messy and noisy information and organize it. If you look at the sequence on the slide, first we identify the concepts, the key concept from the knowledge corpus. We categorize them, or here I'm saying that sort them into boxes. Then we connect the dots. We connect how these concepts are connected to each other, right? Now, when I'm identifying the concepts, in technical terms, this is called taxonomy or the common vocabulary of that particular knowledge corpus. And when I'm tying those concepts into a relationship, or I'm connecting the dots, that technically that is called that ontology or the semantics of that particular knowledge space. And that is and finally we save that ontology or that structured representation of the knowledge in a knowledge graph. And that is basically how you'll see that humans also study, right? You collect ideas, categorize them, connect them, and then you can use that structure to answer questions faster. A small world model is a mini version of the topic that is relevant, like a study guide, but more structured and connected. For humans like us, our brains do a lot of this automatically. There is something inherent in our brain that is constantly extracting these concepts and then mapping it to a known semantic model. We build mental models from experience and learning without thinking about it. But for language models, we often, or I'll say we always, will need to build or provide that small world model. so that the model has the right map of the topic to navigate before it answers from that model. Now think of the small world model as the navigator or the GPS for the language model. When a user asks a question, what are the benefits of exercise? The system does not want the language model to just freestyle answer it. It first pulls the relevant or the most relevant facts like cardiovascular health, stress reduction, energy from the knowledge graph that we created earlier. Then it, using that extracted knowledge segments, it crafts a prompt that includes those extracted or retrieved facts so that the response is grounded to those extracted facts and is very focused to answer that question grounded to the knowledge corpus of the organization. And this is how we reduce hallucination and increase the relevance of the output from the language models. Now we zoom into the part we'll um, learn as part of this course, which is prompt engineering. I will teach you some um, patterns and best practices. And once we learn it, we can reuse it for almost anything that we want from a language model during our studies, during writing a summary, writing a essay, brainstorming ideas, coding, or planning any task. Right? So a well-structured prompt has roughly 4 components: a role, instructions, context, and output format. The first component, role, is when we tell the AI or the language model that you are a travel agent or you are a biology tutor. We are setting the style and perspective of the language model. It is like casting an actor in a role. A tutor explains step by step, an editor focuses on clarity, a debate coach challenges your argument. The role basically creates a boundary for how the language model should respond. If your role is vague, the style becomes random. A role therefore constrains the language model to a working style boundary that is relevant for that role. Instructions are next. Think of instructions like the rules of a game. If you want a good outcome, you have to define what good means. For example, explain it at a 10th grade level, use bullet points, include one example, do not use jargon. These are instructions that I'm giving into the prompt so that the language model knows what good looks like, right? What instructions, what it can do, what it cannot do. That tells the language model exactly what to do and what to avoid. When instructions are missing, the language model will fill in the blanks with guesses, and that cause hallucination. Third part is the context, and context is everything the language model should know before answering. If you just say, help me study for my test, that is vague. But if you add, the test is on photosynthesis, I struggle with the light dependent reactions, and I have 20 minutes, and this is the content from which I need to answer, then the AI can aim correctly. Context sets the boundary of knowledge for this question right now. The last but not the least is the output format. Even a correct answer can be annoying if it is not organized. If you tell the AI exactly how to format the output, like a table with columns or a checklist or flashcards, then you get something you can use very efficiently. In fact, if it is in a structured format, like how it is represented here, where if I am looking for an air, if the language model is generating an airline booking result, and if it gives me in a structured format saying that this is the flight ID, this is the airline, this is the origin, this is the destination, if it is all in a structured format, it is easy for me to parse and also use downstream applications which can consume this information in a more deterministic manner, right? So whenever we want consistency and structured response, we use this recipe, right? We use um, output formats. So the template for this prompt engineering technique is role. Like role is like you are a what, right? You define what you want the language model to assume, right? What it should, what kind of a role it should assume, right? Instruction says like do X, do not do Y, keep it to Z, right? Give the instructions to create a boundary within which it needs to work. Context is here is what you should know, and format is like return the answer as, and you give a structure, right? That is the end of the theory part. Let's end our session today with our first hello world prompt, right? Let's go to the prompt. I ran it already. I wanted to show um, all the things that we discussed right now, how it is coming together in the prompt, right? And in the next session, we are going to go in depth in more details about some of these patterns and some of the best practices of writing a prompt. So don't worry about all this markdown templates. When we do hands-on, we'll explain why it is required. Now in this prompt, if you remember, we spoke about role, right? I'm giving it a role. I'm saying you are a 10th grade biology tutor. Explain mitosis in simple language suitable for a 10th grade student. This is where I'm presenting, giving it a role. Then I'm giving it instructions in the form of rules that it must follow. I'm saying use only the notes provided below. Do not add outside facts or extra details not found in the notes. If something is missing from the notes, write exactly my notes do not include that detail. Keep the tone friendly, clear, and not too long, right? This is the instruction part. And this is where I'm giving the context, right? And this context is grounded to the knowledge I want it to refer to, right? Here I am giving the definition of mitosis, the goals, like all the knowledge that is required to understand mitosis. That is what I'm giving as part of the context. And in the output format, I'm specifying how the language model should output the result, right? Output the response. I'm saying the output should have a 5-bullet summary. It should have the phases table should be in a table like this, and then also generate some quiz questions for me, right? When I ran it in ChatGPT, which is using ChatGPT 5.2, I could have used any other model also, right? See, when it ran, it gave me the response exactly how I told it to in the output format. I have a 5-bullet summary, right? There are 5 bullets here. Mitosis phases, it is giving me a table with 6 rows. That's what I told, right? 6 rows, give it in me 6 rows, right? And then quiz questions, right? I said give 5 quiz questions, and this 5 quiz questions it has given to me, right? So this is a very basic example of how we structured a prompt with a role, with an instruction, context, and output format. In our next session, we'll do more hands-on on different patterns of writing prompts and see the output. For now, thank you.